What kind of research is needed? Engineering-based science research is now gaining importance. Now it is not the time of this basic research. This is time for the engineering-based science research. Target what technology you are going to develop and apply the basic research to develop it. Target must be first. What is your objective of the research? This is most important today. This is not like to do the Newton's law, do the thermodynamics, do other fundamental principles. These principles, how you are going to apply to develop the technology. That is most important point of nowadays research. You could see all disciplines are merging together nowadays. And nanoscience give the oxygen to all this. We are waiting for them. So when it was started in 1956 with the few questions raised by the Nobel laureate Siemens, that is, we can manipulate the material atom by atom. Why cannot we develop the control system at the individual atoms? Why cannot write the human knowledge at a pinpoint? Why cannot build such machine to accomplish this task? These many questions are the origin of the nanoscience and technology. So let's see about the materials. Different chemical composition, you could say, chemical composition. And you see different structure, chemical composition, structure of any material. Maybe biomaterial, I don't know. Chairperson may know a lot about the bio. Okay. But properties of any material depend on the two parameters. This one is the chemical composition and the structure. What nowadays issue is being changes. Properties depend on the size of the particle. You have to notice what is remarkable. This is silicon is the basic material, centimeter size, micrometer size, and nanometer size. What is going to change? Basic visible characteristic properties. Why? Very simple physics over there. You could see quantization, quantum confinement. Quantum means a small confinement space. A space, a small space the material had is the net. And very basic principle I would like to tell you. This energy of the particle is depend on the square, inversely proportional to the square of the size of the particle. This principle is not only from the quantum mechanics. This principle is from the Gita. Always you, I know everyone is knowing Gita. Gita, there is reported the Trichi particle, a small particle, more energy. Once I have been in Russia, I heard from my mouth of the pupils Trichi particle, which is the Russian word, and it's a Sanskrit word. It is reported. So this Trichi particle, the origin of this technology, from long back with us. So once you apply this one, smaller size, okay, what is E? Is wavelength. Wavelength, you got the different colors, left and so on. So what is going on? This is energy is inversely proportional to wavelength. Now you correlate this relation with us, okay, and you could find the 10 micrometer particle, okay, and decreasing the size of the particle, decreasing. This is called the quantum confinement. Okay. Now, another parameter is the surface area. You all know about it. We do not discuss a lot. But 21st century material is the wonderful material. This one is the graphene. But let's start with the some story of the graphene. Very interesting story of the graphene. There were two scientists. You all know about the Prabhakar and Jain. They have the project of the carbonous nanomaterials. And they gave a pencil, graphite to their students, rubbing on the paper. They passed 3 years, 4 years. And ultimately, objective of the professors get the single layer of the carbon. This is what? The single layer is the graphene. This concept, our young student can easily understand this concept. This is the stick of the papers. Apply the force. Remove the one paper. This is one layer of the carbonous nanoparticle. That is the graphene. So by the pressure method, you can also develop the graphene. Now there are several applications of graphene, unlimited application where it could could not apply. I cannot find where there are not application of the graphene. Now, but one example is very important to you for the graphene as a coating material, functional value and decorative value. There is a traditional coating. A lot of beautiful colors are in traditional coating. You apply the different type of the. What about the lifetime coating? Life of the coating. That is most important. For example, you see the Ajanta Ellora coating is very specific. Okay. And in that coating, corrosionless coating is. Now it is still bright. So this kind of the coating, how we can learn from the nanotechnology? You could see. This is what there are the three pictures. Number one, 10% additives of the micron size, 0.1 additive nano size, and 0.01% additives. Okay. What is specific in that three cases? You see, reduction of ionic permittivity, okay, reduction of absorption and diffusion, reduction and absorption and diffusivity. Okay, how it is possible? This is ordinary coating. The reduction is very high. Now, this one is the graphene-based coating. You see, the ionic permittivity, absorption, and diffusivity, these all parameters, okay, decreases. And lifetime of the coating, that is the big issue. Corrosion is the big issue. Then what happened in that picture, which I would like to see reduction in corrosion current density. This is, hydroxyl ions, they are responsible, chlorine are responsible for the corrosion current density. This is coated metal substance directly. And this one is the graphene coated. You see how wonderful picture of the graphene. This is the reduction of these corrosion parameters. And that will enhance the lifetime of the coating. Another parameter is very important, coating without graphene. Scratches are there. The material is used without graphene. Scratches are there. Then flexibility of graphene is very important. You could say coating with graphene. So it is scratches. That ultimately so to increase the resistivity, corrosion resistivity of material, and increase the lifetime of the material. Now there are a lot of methods, so many methods of the graphene synthesis. You well know about these several methods, but hammer method is most important. We have to apply in all. So what is the future of the graphene? That is 278.4 million USD by 2020. Big business. You can think about the startup of the graphene. How big future is that? Now graphene agriculture context, that is graphene coating in food material. Okay. That will enhance the lifetime of it. That is one option, one application of the graphene. Now this is the several methods for bottom up and top down approach of the synthesis. But this well known, but this method is most important. LAL method is most important. That is applied in liquid as well as bottom up approach and solid liquid interface. In that case, we have to use the laser. And very beautiful results of this method is that ignore the agglomeration of the nanoparticles and uniform distribution of nanoparticles using this method. That's why it is the important method as compared to the traditional methods. So these are the physical synthesis, green synthesis. There are a lot of work is going on in green synthesis. Sometimes we use the leaves, stem, flowers, and so many things, and fruits and so on. This is well known. But last time I was in Europe and I have seen the people applying the poppy seeds without any chemicals. And they didn't tell me the protocol of this development of nanoparticle. How Gaur nanoparticle uniformly developed. Poppy seeds are also very important in green synthesis methods. So this is just like one of the protocol for the green synthesis method in my laboratory. And this shows the antioxidant properties of the bimetallic, trimetallic nanoparticle we are using. This copper, silver, gold. That is the trimetallic material quantity. This is one efforts we made, but we found that size of the particle is not uniform by biological methods. The size of the particle is not uniform and less stable, not more stable. Still, we apply for the antioxidant property. Then we found that the trimetallic nanoparticle having the good antioxidant property for application point of view. Now, this is just like a concentration and the antioxidant properties of that. These are the characterization method. The main focus on this topic. This is the central point of my presentation. Why we chosen the application of the nanotechnology in agriculture? So that we know that the traditional methods not able to increase the productivity, nor store the ecosystem damaged by the existing technology. So what we are expecting, efficient resource utilization and human resource development in that direction. Mechanism of action of nanosensor, nanofertilizer, and nanopesticides, so that using this kind of product, we can store our ecosystem. And there are huge scope in that direction for the development. So application of nanotechnology and agriculture. So you could see there are several areas. Crop improvement in terms of the nanoparticle development for efficient gene transformation. So there are work in less laboratories in India, but a lot of laboratories in Europe. The people are working on that. Secondly, precision farming. So how nanosensor observe the pesticide, detect the pesticide or other soil and water contents are. So soil and water treatment. How we apply the nanotechnology for the soil health and water health. We apply the membranes, nanomembranes, and nanosensor for the detection of the soil contents. And agriculture engineering, in that case, biosensor play very important role, and smart machines like tells the information of the farming field as well as weather and so on. And storage and transportation point of transportation of the material, in transportation of the agriculture product and storage. That is very important area because storage contaminated by the several type of the disease like the insecticide, pesticide, and so on. So how sustainable application of the pesticide, how sustainable application of the insecticide, that is the most important to save the health of the plants. So there are several applications of the that is nanotechnology in agriculture. This is one example for the crop improvement. So DNA, how to deliver the DNA, nanoparticle and delivering DNA into the isolated plants. And this technique has been applied to introduce DNA successfully by tobacco and corn plants. Okay, and this is reported in this literature as well. The DNA sequencing using the graphene nanoribbons. The result of this experiment, you could see this picture and this picture. There are a lot of difference. The growth of the crops. Now, next one is the nanotechnology can help crops to grow faster. Carbon nanotube is applied for this point of view, and 10 to 40 microgram compared to the control tomatoes in case of the tomato. So this is the results of this experiment, and this is reported in 2009. You could see the control shoot, that is length, deep number, and root number, and finally, if it is 0.05 microgram per liter is applying, then this observed data is better than the others. Okay, this is one report. Now, effect of the silver nanoparticle on seed germination. So germination is the one of the big factor in agriculture. Germination is healthy or non-healthy. These two germination is good. Definitely, the product of the agriculture crop is far better than the others. So germination point of view, This is one is applied for the, this is, we could see in that case, the silver nanoparticle of the different A, B, C, and D. This is A, B, C or different concentration. This is 10 microgram per ml and 20 microgram and 30 microgram. You could see this germination picture of the silver nanoparticle as compared to control, and this healthy germination was observed in that case. Now, next one is the effect of the silver nanoparticle seed generation of this one example of the fenugreek seeds. In that case, you see the germination percentage and the speed of the germination. So 10 microgram per liter, that is the germination, is the 70%, 76.11, and that is the speed is higher. You could see that particular concentration represent the germination percentage is higher and speed is higher. This is the one of the results reported in 2015. And now there is the nanotechnology for the pest management. There are the two things, target organism and non-targetable. You cannot apply directive. The pest insects are the target. Okay. How this technology helps? Nanopesticides, what are they? They are the active ingredient of the particle size less than 100 nanometer. So formulation of the nanomaterials, nanoemulsions, and nanosuspension, nanoencapsulations. Okay. So you could see the example one by one. The silicon nanoparticles, okay, mediated insect pest management. You could see in that case, this is silicon nanoparticle is applied for tryphoid infection. And this is act as the pheromone carriers. So this method can attract the pest or insects as well as, and act as a plant growth promoters and reduce the defense mechanism, the plant growth, and acts as a insecticide carrier, acts as a insecticide molecules. So this is the one example of the silicon nanoparticle. So DNA tagged whole nanoparticles, a new tool to control the S litura. Okay. So DNA tag. So in that case, I would like to show the example. This is what happened. And there are the results of that. So 5 days after treatment by the DNA tag whole nanoparticle, and this is 6 days after treatment, and this is the 7 days after treatment. That means this gold DNA tag gold nanoparticle directly hit the target. Okay, and this is controlled. There are no change at all. So what is the results in that experiment? That is second, third, fourth, and fifth day. Third, fourth, and fifth days. So you see the ppm level which is being applied, and in that case, this is 500 ppm gives the better results as compared to this. So DNA tagged gold nanoparticle is useful for the pest control. So another important area is the development of insecticidal nanoemulsion with Manicara as extract. So this is natural extract from the fruit of the Manicara, and it's a tri-repens active against cotton pest. That is most important for the cotton pest. Nano emulsion is safe for the non-targeted material. So nanoparticle in insect, the ferromagnetic nanoparticle, we all know the ferromagnetic materials are abundant in the heads, crops, and abdomens. So that is reported in 2005. And nanoparticle in disease management, crop protection are suggested. Silver nanoparticle, copper, zinc, and silicon nanoparticle, as well as nanocomposites are. So antifungal effectiveness of the nanosilver nanoparticle, this is already available, and indigenous technology, but it needs a lot of improvement. So for example, photograph the leaf with the powdery, okay, mild leaf. In this case, you see before treatment and after treatment. You could see the flower before treatment and after treatment. Okay. There is a lot of change in the health of the flower. So this treatment is the nanoparticle, which is definitely used The positive charge of the tissue interact with the negative charge phospholipids components of the fungi membranes. So how to control the membranes? How to control the fungi? By this way, this particle is most important. There is a simple physics that is of the positive and negative charge. They interact together. So that is used for the control of the fungus. So nanosilica part, nanosilica gets the absorbed into the lipid of the cuticle organisms and the causes death of the dehydration. That means this nanosilica is responsible for the death of the insects. So nanofertilizers, this is most important for high absorption, increased production, photosynthesis process, and leaf surface area expansion. The leaf surface area increases and expansion of the leaf surface area that directly affect the production. Okay, and definitely the application of the nano urea can save the 20.12.4 and 4.7% nitrogen application to the soil. First evidence of the film transport of the nanoscale calcium oxide in groundwater was reported by the DPITR 2014. So there is the application of the nanofertilizer for the good production and starch-based nanoparticle. So this is one very important application of the nanotechnology in agriculture area, because agriculture nanotechnology can apply to sustainable production methods such as organic farming, organic nature. Now everybody is looking for the organic farming. So Department of Agriculture, Government of India is carrying out a project for the development of the starch-based nano containers for the delivery of the nutrients, biostimulation, and crop and production molecules into the plants. That means that how we can deliver the fertilizer, how can deliver the nutrients in plants. Okay, so that is most important and challenging area to develop the nano carriers. So the clear advantage of this approach is that starch is a biocompatible, biodegradable, and non-toxic plants, animals, and the environment. So if starch is applying as a nano carriers in the area of nanotechnology, then definitely we have the dream of the sustainable agriculture. So why fertilizers? You could see the result of the nanofertilizer after 65 days. This is the size. So we could say the 30% more nutrients mobilization by the plants. Okay, 70 to 54% improvement in the crop yield. So this is the several products available in market, but modification or changes or improvement everywhere needed. So soil management, in case of the soil management, American scientists developed the soil set, soil binders, okay, to prevent the corrosion of the soils. And precision of farming. If I would say, there are the sensors, dust, nano dust in a farming field, and that will give the information of each movement of the soil and crops. So this is the dream. How to develop the nano sensor? You have to put in all corner or all area of the crops that provide the information. This is what IT based technology by using nanotechnology. So food packaging, I just mentioned about the graphene. Graphene is the powerful material for the food packaging. Graphene layers and polymer matrix are capable of producing a protein spar which act as a barrier for the gases. You have seen the part earlier in graphene. Okay? And that will act as a barrier. Okay, for the different type of gases. So we can increase the life of the packet, means packed food hai, uske life by this way. Removal of heavy metals, that is nano membranes, with the heavy metals in water, then how to develop the nano membranes. Remove the heavy metals so that heavy metals may not introduce, okay, may not taken by the crops. because it will have the adverse effects in crop health as well as human health. So risk of the nanotechnology, nanoparticles could be inhaled, okay, absorbed through skins. Nanoparticles can accumulate in soil, water, and plants. Therefore, care should be taken while working with them. So, conclusion: nanotechnology is the revolutionize agriculture and horticulture by new innovative techniques. Nanotechnology could be used to increase the disease resistance in silk worm and thus enhancing silk production. Through nanotechnology, more precise diagnostic tools can be produced for early detection of pathogens. Nanomaterials have the great promising future for the modern. So live green, go green, and pray for green. So thank you very much for your attention. Thank you.
Understand the way simplified is related
अब समझ में नहीं आया किसी को.
so that was I can also just see whether they can the power of
Actually, madam, depend on the characteristic property of the material. What kind of the material? For example, if carbonous materials are there, they have the not big toxicity is less. If you have chosen the metallic material, so metallic material, there are the chances for the cancer. There are atoms, a lot of this. Yeah. Yeah. Actually, I cannot guess the cost, but if we change the synthesis method by natural synthesis, biosynthesis method, we can definitely reduce the cost. We have a lot of biomaterials. Yeah. Instead of using gold, just I have given the one example of the poppy. Okay. Poppy seeds used to develop the huge amount of the gold. So natural method means eco-friendly method. You have for biosynthesis method is the eco-friendly method. Chemical method is not eco-friendly. We talk about the sustainable future. So we must apply the eco-friendly. So this is the thank you. ऐसे मोमेंट को मिलेगा क्या? एक तो मिल चुका है. Now I will control Dr. Please take a moment to learn.
कविता वो मुझे लगा चेयर तो ये है सब्स्टिट्यूट
यूनिवर्सिटी कमांडर है.
Now I would like to invite our next speaker, Dr. Gajendra Pratap Singh, who is from JIIT, and he's going to talk about graph theory and Petri nets, powerful tools for biological modeling. He is assistant professor at School of Computational and Integrated Sciences, specializes in graph theory, network optimization, graph algorithms, and programming with a strong focus on mathematical modeling and computational tools. His research interests extend to the application of advanced algorithms for solving complex optimization problems in networks, as well as exploring the behavior and structure of networks through the lens of graph theory and Petri nets. He has contributed significantly to the field with 51 publications. His work addresses both theoretical and practical aspects of computational sciences, contributing to the development of efficient algorithms and models that are relevant to real-world applications, such as communication networks, transportation systems, and complex data structures. In addition to his research, he is dedicated to teaching and mentoring students in the areas of algorithm design, statistical analysis, and computational tools. He emphasizes the importance of using programming and mathematical tools to solve intricate problems in the modern computational landscape. His research continues to influence both academic and practical advancements in network analysis and optimization, making him a key figure in his area of expertise. I welcome Dr. Gajendra for this.
Thank you very much, Dr. Ranjana, for the introduction and distinguished chief guests and my colleagues, speakers, students. So this is the opportunity in this conference, although this is it looks like the outlier using mathematics in graph theory in several areas, but you will enjoy it. I have I will show here only relevant examples, practical examples, so that everyone get understand how we can use the graph theoretical concept. As Professor Gaur listed here, nanotechnology is the mother of all sciences. Like he has a kind of if nanoscience is the mother, so then graph theory that is the one kind of bond to finding the oxygen molecule. We said nanotechnology is the oxygen. It is if we use the graph theoretical approach, the graph theory in complex system or any biological system or any computer science or any system which is not easily understandable or very complex or it is tricky system, graph theory can help to study and also the practice to study such kind of system. So here I will present some applications starting with the introduction of the graph theory and the practice. What is the graph theory basically? For example, we have molecules or nanoparticles. We have some kind of elements or atoms. But how they are connected to each other? If you want to know how they are connected, what is the behavior or what mechanism or in what pattern they are connected. So this is the one very fundamental concept graph theory. We can study, even we can see the internal behavior. We can study the internal behavior inside the system, complex system. For example, stone, graphene, and a graphite, some and you have seen that is a one kind of crystal structures. It is very difficult whenever we have number of molecules or atoms are more millions, billions. In that case, very difficult. But if we use such kind of that makes easier. I'm not saying it will give you 100% solution, but it is good if you use that. We will get some basic idea how to start the study. We will get some such kind of ones. So let me start here. For this, some machine learning techniques we also needed. If we are good programmer, then we can write a program and we can automate the sequence of firing. Firing means we can automate the tasks or actions in a particular order and sequence. Okay, I'm coming here. Now you can see, I will show the relevant text here. These are the systems, very complicated systems. We cannot study that. So here is some applications you can see here in diverse area, Petri the graph theory. This is a pictorial paper. That means whenever we model, what is the idea of the graph theory? Right, graph theory has some kind of nodes and the interconnection. That is a basically basic fundamental definition of the graphic idea. We have more molecules, some bonding is there, or if they are related to each other, we can join those bonding or those kind of distances by an H or by an R. We can join. That is called link or interconnection. That is an idea. So here I will use the concept of the Petri net. Petri net also a graph theory part, or you can say it is generalization. Difference is that in Petri net the graph theory used for a topological study. But Petri net we can study the internal behavior of the system. That is the main difference in the Petri net in the graph. And Petri net is a directed bipartite graph. Directed bipartite graph means we have set of vertices. We can divide the vertex set into two disjoint subsets. For example, in this class, in this room, we have female and male participants. We can divide male different segment and male is different. Assumption is that no female interact each other. Similarly, man cannot interact each other. Male can interact with female, or female can interact to male, even a modern. So that is the concept of the basically directed bipartite. But if we assign the directions, that is called the directed bipartite graph. Petri net is the directed bipartite graph in some additional conditions. That condition is called the marking. So we have two kinds of nodes. One is the boxes, one is the circle. Circle is the place node. Box is the actions. Whenever some kind of activity or actions is there, we denote by the action is boxes. That is called the transition. Transition activity or action or any kind of event. In the place node, it is stable. That is a place node, and the arrow represents the connection between the place node and the transition. That means arrow means place is the dummy thing or stable thing, and transition is the actions. That means we can connect place to transition if they are associated, but we cannot connect place to place directly because it's directed by the graph. For transition to transition directly, we can connect place to place node by a transition, and transition to transition by a place. We can put by an arc or directed arrow, and the dot inside the place that gives us the number of, or you can say it is the capacity, number of persons, number of entity also, or any kind of goods we can have. That means it is a place. Place can accommodate as many as persons. For example, this is the room. We have the finite room bounded. This it has some kind of certain kind of bounded capacity. Sitting capacity is suppose 100. We can accommodate only the place node or this room only 100. So that is some kind of thing. All 5. So that is the definition component. So now that is the definition, formal definitions. I'm not going to elaborate here because several participants, our colleagues are mass background. I can give you one example here. This is a very good example for firing rule to see the internal mechanism, the behavior of the system. That means you can see here I minus. I minus means it is a I minus means it is a number of arcs connected from place node to transition. That is an element of the I minus. and mu p means number of tokens or dots inside the place. Okay, that means number of arc placed to transition is less than equal to number of token in that input place of the transition. If this condition holds, that means transition is enabled. So transition is activity or any kind of actions. It can be enabled. Now it is up to us. If event actually take place, we can fire the enabling transition. If even not take place, no need to take firing of the transition. That means before the firing, we have some kind of state. After the firing, whenever we fire the transition, we will get a new state. That means state of the system has been changed. That means we are going to study the dynamics of the system. Internal, I can show you the example. Now, it is a graph, very small graph. It has two places, two transition, and one place has two tokens with two dots. The state of the system is 2, 0. Place P1 has two tokens and two persons, and place P2 has no token, 0. That means 2, 0. Okay, so here you will check the enabling condition. Number of arc from, you can see here, this one, arc condition. Number of input place. State. You have number of before the fire. After I minus this case to transition and I plus reverse transition to minus 1 plus 1. If you use this, you successfully fire the transition. Again, we will check the every rule. Again, we will fire. We will get such kind of states here. I'm showing here all the possible states. That means now we are studying the behavior of the system. Earlier, very small terms. So if you change the program, right, then the state you will get a drastic change. You will see the state. I will show one level. So that is a basic idea and fundamental principle. Okay. We can also express these marking vector in terms of the tree. I'm showing some application. In series sequence, we can use sequential behavior. Whenever we have, you can see the state token movement. This is the sequential behavior we can use. Whenever we have sequential tasks, we can model this kind of situation. Any biological, any complex system we can. This is a system complex situation. Whenever we have more than one activities are there at a time, only one maybe can happen, one activity. Rest will be disabled automatically. Complex situation can be modeled with the help of Petri. Also, convenience situation we can take up with the help of Petri. That is another beautiful example of the Petri and advantage. We can model the synchronization situation with the help of Petri. Mutually exclusive we can model. And let me show you one more. There is one more example. You can see that the example. We can model very small examples for modeling the traffic slide. We have 3 lights. These are stable. You can take red, green, and orange. Take another place node and start off any kind of light can be taken as transition because it is activity. We can model like this, and the dot represents the particular light is going on. Whenever transition fire start to yellow, now green is going on. In this way, we can model like this. Another example. This is the interpretation. You can see here. Transition can be taken as event transformations. Tokens can be human, goods, and any kind of machines. Other example, suppose very small example application here. We have system equations. We can model. Suppose we have 3 equations. Every equation can be taken as a transition because it is a active. And the molecules, carbon and oxygen, can be taken as place. Okay. And a dot represents oxygen, amount of oxygen present. I'm not saying how much is present, but that can be also we can handle. There is another classification of the bacteria that is called the continuous. So I'm using the ordinary bacteria here. Initially, carbon oxygen is there. Whenever they got some condition, enabling means some temperature or something. they have some suitable condition. Then carbon, oxygen, they will combine each other. They will release the oxygen, carbon dioxide. Ready? So now token movement you can see. So that means token is now when it is combined. And it's combined with Cl. Now you can see the movement. Before that, you can see the movement of token. After movement, you can see that it is. In this way, you can model an equation or an equation in this. So that's the benefits of several chemicals. I'm not showing this one, but I model this. I also model to check whether the biodiversity is sustainable or not. I model this. I'm skipping. Yeah, okay. And some puzzle we also model here. Okay. Now I want to show you some demonstration. This was the slide. How the I'm connecting just one of this. I'm taking one three places the transition and then some kind of crystallography structure. It is basically it is an n-dimensional cube. We can now little bit change. Now you can see that based on change the internal behavior of the system. Here the system that is crystal structures. That is also used in for reduction that dimension reduction to the and higher dimension. And exponentially exponential. Very difficult. Today, do not have a technology. Whenever we have both the kind of n to become n number. It is a very difficult. Hard to be not able to compute. We see exponential whenever. But here the big we have also some kind of concept. We can also restrict, we can also make the infinite system which reduce to the bounded system or finite system. We have that by using some machine learning. We did in our lab. In our lab, we developed two kind of theory. One is the Boolean factor, second is the binary. And that application of that kind of theory, we are applying in theory procedure basis. and also the cell division. Basically, whenever cell divides into two sub mitosis and some other part, again it divides. So we are using those. That was I. And we also this is continue. Thank you.
For that whole problem of traveling for how many suppose
Yeah, we can. We use the practice. Competition we have done. We have developed algorithm. But if we use the practice, get the alternate. We can use it to the nature description condition. And anytime we can switch the practice. So we can continue till our child achieve. Those are the variations. Student continuous hybrid practice, fuzzy practice. Several variations. But in our lab, we are pure ordinary.
what about the error?
Error is some steps. You can check some type of the error. We assign the time. Now I have the transition file time. But if you assign the transition file time, whole transition time, so that you will get some complete good results. We can also check. Or just
You can have discussion on the lunch.
Thank you, sir. I will request to the ma'am. That a moment.
yes.
Now I would like to invite our next speaker, Dr. Kavita. He is Assistant Professor at School of Environmental Sciences in JNU. His research focuses on the health effects of electromagnetic radiations, biomedical applications of nanoparticles, and the therapeutic potential of plants. He earned his PhD degree in environmental sciences from JNU in 2014 and expertises in molecular biology, biotechnology, plant biology, nanotechnology, and microbiology. And he has published numerous research articles with H Index of 24 with over 1,600 citations. I welcome Dr. Ram.
So, so title of my talk is biomedical application of BSA. Basically, in our laboratory, we are working with different kind of nanoparticles. Some are the metallic nanoparticles, some are the non-metallic nanoparticles.
and different aspects of nanoparticle. Nanoparticle for this health issues, their health risk assessment, environmental application like wastewater treatment, degradation. Here we are going to discuss about the biomedical application of nanoparticle. This was very early work when I was doing PhD. That time we synthesized this carbon dot nanoparticle by using this very simple method. We use this lamp filled by the mustard oil, and then we put the copper plate on that, and then synthesize the copper carbon dot nanoparticle, and they have very high fluorescence intensity. So we use that nanoparticle for this imaging purpose, and they show very good fluorescence intensity. If you see in the, normal cell and cancer cell, so cancer cell internalization is more due to the more pore size. Then we also use this quantum dot. Now people are using the quantum dot nanoparticle for this cancer imaging. But quantum dot nanoparticle, it has a good fluorescence intensity, but problem is that this toxicity of cadmium is a very big problem. To sort out this problem, we have synthesized core cell structure. In the core cell structure, we made the CDSE coated with the CDS. So it reduce the toxicity as we compared with the CDSE. This paper we also published. And further, we also synthesize the ZNSE because CDSE has the toxicity to overcome this problem. We synthesize ZNSE. So ZNSE also has very good fluorescence intensity and very high anti-microbial activity. We have also did some work with our collaborator in Japan. So we synthesizing nanoparticle boron carbide, nitride nanoparticle, and used for the BNCT. And in that, we found very good results. If you see, we have seen in the cancer cell and normal cell, there are not of sensitive, but cancer cell, they have shown very good anti-cancer property. And if you see this, we have treated with the thermal neutron, and then boron, they due to the thermal energy, they kill the cancer cell. This gold nanoparticle we also synthesized by using this opium teniferum, and we have also synthesized chemical method, and we found that green synthesized one are more fluorescent as well as they have the more anti-cancer property because we are compare both. And now we have to come to BSA nanoparticle. Why we are using BSA? Because BSA is a non-toxic in nature. They are a good carrier and they are used in normally the biomedical application. So we have synthesized the BSA green tea polyphenol nanoparticle. We have taken this, we extract the green tea polyphenol from the green tea, and then we have make a BSA as a matrix coated with the green tea polyphenol, further coated with the chitosan because chitosan is a surface modifier. So, and use there because when we are doing this radiotherapy, so radiotherapy kill the cancer cell, but sometimes they also affect the normal cells. So these BSA nanoparticle over objective are they have the radio protection effect as well as they have the anti-cancer property. So both property they have shown. So there are different chemical structure of green tea polyphenol, chitosan, epicatechol, epigalative ECG, ECGC, and you know that what is the problem? If you see the problem with the green tea polyphenol, their bioavailability to tissue is very less. Their stability is a very big problem, and another problem is the potential toxicity. That if we give it the BS green tea polyphenol as a drug, it has some allergic reaction or some toxicity to cell. To overcome these problems, we have synthesized nanoparticle with the BSA, with the green tea polyphenol. And then if you see that here with the TAM and SAM, so here if you see that size of this, and when we coated with the drug, the size is significantly increased. I will give you that outside. We did this particle size by the SAM, it was 9 nanometers by the BSA nanoparticle. Then BSA green tea, it's a 17 and coated. If we further coated with chitosan, it's increased to 21 nanometer average size. Surprisingly, we find the zeta potential is negative because BSA is a protein, the zeta potential negative. So when we do the surface modification by chitosan, the zeta potential is a significant increase. And when the zeta potential increase, it is said that when we see by the DLS, there was the agglomeration when we are working with the BS and nanoparticle. But when we modify the surface, its agglomeration is reduced and its average size passes by DLS is 285 nanometers. It has also very good drug loading efficiency and drug interference efficiency also. Then we also seen this in vitro release assay in all gastrointestinal stages, starting from this starting from this saliva, then we have to go to intestine, then or ileum. So it gives the very good stability. Then we also did the antioxidant assay. It's so very good antioxidant property because it has a very good interference efficiency of this polyphenol. So that's why they have the good antioxidant potentially. Then we did the in vitro study. So in vitro study, what we did, first 3 days we did the treatment of this green tea polyphenol, nanoparticle as well as the polyphenol only. Then after 3 days we give the radiation, gamma radiation, starting from 4.5 gigahertz to 8 gigahertz, according to this experiment requirement. Then after 4 days, we after 24 hour treatment, we isolate the splenocyte, and then we measure the oxidative stress, DNA damage, apoptosis, redox signaling. After 1 week, we measure the hemopoietic assay or hematological parameter, and after 11 days, we found measure the spleen colony assay, and for survival, we have taken for 1 week. So if you see the experiment, this you can see this red one is the radiation group. So the control group they survive. Radiation group they have survived up to 21 days. When we give this green tea polyphenols plus radiation, they will this IC50 was around around 17 or like that. And when we give this nanoparticle treatment, this IC15 significantly increase. It's so that nanoparticles they have to survive this animal and they protect the radiation. We also did some. This is the whole body exposure by 7 days effect on the hematology parameter, and you find that lymphocyte, platelet, and other hematologic parameters is responsible for the immunological reaction are significantly increased. We also did the study of this effect on this reactive species or ROS production, because radiation is mainly responsible for the ROS. If you see the mechanism, the primary mechanism of the radiation is the production of ROS, and that ROS may be led to the other kind of consequences. So ROS production is significantly increased in the radiation group, and which was decreased by giving the nanoparticle treatment. Same like the DNA damage in radiation group, there are significant DNA damage. And when we give this nanoparticle, if you see that this is the polyphenol only, and here is this polyphenol plus nanoparticle. So nanoparticles are giving more significant result as compared to the polyphenol. We also find out this depletion of mitochondria, because when we are talking this apoptosis pathway, there are the two kind of intrinsic and extrinsic pathway. So our mechanism was following the intrinsic pathway, so mitochondria is affected, and mitochondrial membrane potential is significantly decreasing. That lead to this apoptosis. So apoptosis also significantly induced in this radiation group, but it reduced by in this nanoparticle treated group. We are also to validate our results. We also did the antioxidant and enzyme assay and find that this antioxidant enzyme is significantly reduced. We protect this animal for the radiation effect. We also did this expression of this enzymes. Some genes are play important role in this oxidative stress pathway and apoptosis pathway, and that their NRF2 is significantly increased, and similarly bags is decreasing. We can say from this that this green tea polyphenol it play as a protective role against the radiation-induced toxicity in this. Then another study we use this, the Cordyceps militaris. Cordyceps is now a very famous for Kida Jadi. Everyone was are working on that. But problem is same like the problem is the bioavailability as well as the stability is a very big problem. And it's very costly. If I'm talking about there are two species, Cordyceps sinensis and Cordyceps militaris. Cordyceps sinensis cost is if I'm talking 1 kg cost more than 10 lakhs. And this is not possible to grow in laboratory, it's naturally growing. But Cordyceps militaris is growing in a laboratory, it costs like 50,000 per kg. Problem is that when it's availability, solubility in water is very less. So to overcome these problems, we have synthesized nanoparticle from the Cordyceps militaris extract. This is the HERV project in which we are working. So first we did this. We taken out the extract of the Cordyceps militaris in a methanoic extract, and we did this analysis by the GCMS and LCMS. If we're talking about the GCMS, we found, if I'm talking about 50% methanol extract, we found 47 compounds, but 100% methanol, we found 35% compound. Similarly, by Cordyceps concentration was 8.22% in this 50% methanol. If you see in aqueous, very less concentration of Cordyceps and compound also. So then we did the same method. We use the BSA as a matrix and Cordyceps extract as a we can use as a drug, and then further put it as a cytosol. If you see this average particle size is less than 20 in BSA Cordyceps, and extract is 27 nanometer. Zeta potential when we did the cartosian coating, this zeta potential is significantly positive. Earlier, when we talking about the BSA nanoparticle, is a negative in charge. Then we have also find out the in vitro release, because drug which is good, who has the more availability to cells, so it will be slow drug release. So or drug was a slow drug release, it's available up to cell up to 48 hours. So and we, here this drug loading and interference efficiency also very good. It's a more than 50% in both cases. Antioxidant potential, we did the two assays, DPPS and Abitras assay, and both we find the very good antioxidant efficiency as compared to this drug only. Because to find out what is the possible pathway of this anti-cancer potential activity, so we did the past prediction by using the bioinformatics tools, and in that we find that some genes are responsible, which play a very important role in this apoptosis and antioxidant potential. So we are working on that gene. Yeah, 2 minutes. So we did this is the anti-cancer assays we did. This apoptosis assays. We are also working on this some inflammatory pathway, because if I'm talking about the NFKB, it play both role in it's activate the and inflammatory pathway as well as it activate the apoptosis pathway. So we are working on that pathway. So when we come to the conclusion, so green tea polyphenol nanoparticle, they reduce this free radical mediated oxidative damage, and it's given by ROS, and that they modulate the active antioxidant machinery like antioxidant enzymes, NRF2, and they follow the ERK pathway. If I'm talking this say Cordyceps nanoparticle, they follow activate the NFKB, and which are increase this inflammation and genotoxicity that will lead to the cell apoptosis. So in that case, we can say that if instead of using this metallic nanoparticle, gold, silver, you are using for the anti-cancer property, but somehow they have some toxicity. So, and they are also very costly in nature. So we have to go for green synthesis, especially some plant-based medical compound or plant-based phytochemicals or some that. And if we synthesize nanoparticles from them, that will be more useful. Thank
Nanoparticles, particularly for biomedicine, how they can be exploited because of particular time. Please discuss over the lunchtime. We really need to catch up.
you.
Go and stand with Papa. Now I'd like to request our next speaker, Professor Zahid Raza, who is going to speak on computing paradigms and insight into data processing. He is Dean of the School of Computers and System Sciences. He has MSc degree in electronics, in which he was gold medalist, and TED degree in computer sciences and PhD in computer sciences. Prior to joining JNU, he served as lecturer in Banasani Vidyapeeth, and his research interest is in the area of parallel and distributed systems. He has proposed various resource provisioning models for job scheduling for computational grade cloud and parallel systems. He also worked in the area of machine learning for medical problems, and he has published more than 50 research papers in various peer-reviewed international journals and transactions. And he has been abroad along with contributing chapters in an edited book. He had co-authored a book in Finger Briefs in Computer Sciences entitled Option-Based Resource Provisioning in Cloud Computing. Various invited talks have been delivered, and he has served in various committees for academic, administrative, and evaluation purposes. So I welcome Professor.
Apologies for the delay. Actually, they are loading it from the mail. Actually, sent an email the same because I was myself busy in the inauguration of some function. So, but at the outset, I would like to thank the organizers for giving me an opportunity to come and present my work here. And a special thanks to my colleagues and my friends, Dr. Ranjana, Dr. Kavita, and Dr. Kulriya, because they were instrumental in bringing me here. Even I am really glad to see my colleague, Dr. Gajendra, sitting over here. So by the time my presentation is loaded, I would like to say that mostly you people sitting here are biologists and working in the area of experimentation in which some data is generated, and you analyze that data and then come up with some of the results. And I am somebody actually, who works in the very orthogonal area in which I decide about if an algorithm is there, if some problem is there, how that problem should be executed, what resources should be allocated for solving or addressing that particular problem. So basically, this is my area. I believe I'm the odd man out here, so I've tried to make my presentation as simple as possible. Just to present in front of you the various computing algorithms and rather computing paradigms, which are really instrumental in solving all the large scale problems. And since I remember my colleague Dr. Gajendra talking about mother of computing and something, I would like to say that mother is something who really takes care of everything. For example, if the child says, I want to eat butter chicken, then mother is instrumental in making the butter chicken possible. So similarly, I would like to say that irrespective of from where the data is getting generated, it is all about the computing paradigms, the way the resources are provisioned. So we try to make sure whatever you people demand, whatever the problem demands, and accordingly we allocate the resources for that. So that becomes the topic of my presentation, which is computing paradigms and insight into data processing. Let me just start with a very simple thing. What is computing? Computing is simply a goal-oriented activity in which you want to achieve something. And if you talk about a paradigm, it is nothing about looking at the way of addressing a given problem. So when we say it's a paradigm shift, that means then you are coming up with a computing algorithm that is totally different from what the conventional mechanism is. We say that it is a paradigm shift. Let me start with a very basic thing that why do we need computing? Because although you people are biologists, but still you do compute. I also compute. The basic reason of going for computation is we need the computation to be as fast as possible. We want it to be as precise as possible. It should be time saving and with minimum or least efforts from the programmer or even the experimental analyst who is doing the problem. Of course, with the comfort of sitting at home or wherever the place of work. Ultimately, we want the system to work for you in the least ambiguous way that is possible. But what is the need of time? The need of time is going for a ubiquitous computing setup. What do you mean by ubiquitous computing? In which, when you want computing, the computing is made available to you. For example, if you talk about electricity, if you talk about water, then we say wherever you go, you simply plug in your device and you get electricity. Wherever you go, you simply open the tap and water is made available. So in the similar fashion, if we can have something in which computing is made available as and when it is required, that becomes the need of the time. Of course, it is made possible only by the availability of internet, which has been ubiquitously present everywhere. This kind of computing, in which the computing is available everywhere, also ensures the collaborative nature of the research to be anchored. As you people know, the basic of computer science that ultimately the computer is inspired with human and it mimics the human nature and the human body. So ultimately we say, what is the biggest factor that really influences computing or any decision making? It's of course the nature, because it works in the most balanced way that is possible. For example, we say sun is doing its job, moon is doing its job, all the planets are doing their job. That means all the activities are going on in parallel. Similarly, if you see, for example, right now I am giving the talk here, my mind might be somewhere that, okay, once this talk is over, I have to go and address this thing. And you people might be thinking that, okay, when this talk gets over and we go for a delicious lunch rather than listening to all this nonsense. So ultimately, it's all about parallel. We work parallel. So ultimately, the computer should also work in parallel. So that becomes the inspiration for everything. Let me give you a very simple example of going for parallel computing. For example, let's say this is my daily schedule in which each activity I perform daily is represented in the form of a node. So M0, M1, M2, M3, they all represent some nodes. So for example, I say I wake up in the morning and this becomes my first activity, which is, let's say, M0. Once I wake up, there are two activities I can do in parallel, which I really love, reading the newspaper while having my breakfast. So these two activities can run in parallel because they are not dependent on each other, but they can be started only once the previous activity has got over. Then what I do is let's say, drive to my office. So this is something in which no parallelism should be there, because while driving, you should not take care of anything else, not even attending phone calls. So similarly, as soon as I reach my office, I attend to my emails, I check my boss's instructions. So accordingly, This gives us the parallel nature of everything we do and everything which is possible. This is very small glimpse of how parallelism can affect the computation. If you see the bigger picture, there are so many jobs and so many tasks that can be executed in parallel. So I would like to say that parallel computing is the way ahead, and ultimately work distribution is important or is the solution to the problem of getting effective computation. In general, we say more the number of workers, more the amount of work will be done. But as far as computer science is concerned, we say otherwise. To an extent, we say like two people are company and three people can become a crowd. So if you keep on increasing the number of workers to an extent, it is good, but beyond a certain point, it becomes really bad because it results in conflict of interest. So let me start with a very basic form of computing paradigm, which is the multiprocessor system. Let's say you have a situation in which you have an activity which can be performed in parallel. You have a job which can be like looked at upon the previous example which I told you, in which certain activities and subtasks are there that can be executed in parallel. So how can you execute that? If you have a uniprocessor machine, that means if you have only a machine in which one processor is there, then definitely no parallelism can be taken care of. So the simplest solution to the problem will be if we can have a system in which in the same computer you have multiple number of processors or computing nodes available which can solve the given problem. So this kind of a system is known as a multi-processor system, in which inside the same system you have multiple number of processors available or a multiplicity of functional units available. How you can look at it in a very simple way, like number of cores, multiple number of cores which are available in a given computer. So as soon as your job comes, some number of cores will be designated for that and your job will be executed in parallel. The only issue here is the degree of um, uh, like the way actually all these jobs are bonded together. So this is technically known as what you call as tightly coupled problems. So we say it's just like a pizza. So for example, if I order a pizza in my lab, I have only two students. Okay, we can each have half half. And if we have three students, okay, maybe we can have one third of the pizza each. But if I increase the number of students to 50, and if I have only one pizza with me, then in that case, it becomes a really big problem because the scalability is challenged and ultimately there will be a big conflict of interest. So this is, however, one of the ways by which you can execute your job in parallel, sitting in the comfort of your own room. Another way of going for parallelism is the use of multi-computer systems, in which we say rather than having something which is too much shared, we have a collection of machines which are collaborating to solve a given problem. For example, a railway reservation system in which multiple machines are working in parallel, they are working for the same objective, but they are distinct. They have their own clock, they have their own operating system, they have their own operator. So if the problem is scalable, if you can divide the problem among various entities geographically or maybe in the same room, but you want to distribute the job by involving many people together at the same time, multi-computer systems becomes a solution. They are also known as loosely coupled systems. Let me go a step further, in which I say you have a big problem available in front of you, for example, any image processing problem or maybe any biological problem. Now, what you want a very powerful machine to execute that particular job. What is the way out again in front of you? Can you go with a multiprocessor system? Though it is very good, but it has its own limitation. Can you distribute it among many computers? No, you really do not want to distribute, but still you want to execute it in a most powerful fashion. So there, cluster computing comes into picture. What do you mean by a cluster computing? Like cluster of houses, you have certain number of machines which are clustered together. They share a very high speed network. That means they have a very good bandwidth which is there at the disposal, and it works in the fashion of master slave. That means among all the nodes, the computer will be shown to you as a single computer which is working in a distributed fashion. But what happens is among all those nodes, there will be one computer which will be acting as a master computer, and remaining all computers will be acting as a slave. So it is the job of the master to distribute the jobs, and ultimately the slaves will execute the job and will send the result back to the master. So what is the advantage that we get here? you get a supercomputing machine in the same space in which though distribution is there, though fault tolerance is there because multiple machines are there and they have a homogeneous architecture, but they are all in the same premises and the single computer acts as a very powerful computer. At this point of time, I would like to say one thing. It's always difficult to make a single computer too much powerful rather than having a collection of computers coming together to solve the problem collectively. It's like, you have one oxen which is carrying the cart. How powerful can you make it? Even if you're able to make it very powerful, it becomes very expensive. So rather than having one oxen which is very powerful, you can have multiple such animals which can carry the cart. The same logic goes here. To this point, ultimately, what we are talking about is the computation which is there in-house. That means in the same premises or in the same room or in the same organization. But if we really want to go with a parallel computing way or in a distributed computing way, the driving force is what you call as the internet. The picture here present in front of you, the number of hosts that were connected to the internet or the network. Initially, if you see, till 1995, the number of hosts that were connected were very low. So the reason was the internet was primarily used only for the research purposes. And as you must be aware, ARPANET was born that time. But once TCP/IP was born, once Internet Engineering Task Force was born, once domain name system was born, that time there was a knee effect and the number of hosts that could be connected to the internet really shot like anything. And that led to the boom in internet and the connection of educational, communication, business, and you name it and you have it, all kind of services being delivered with the use of internet. Now we say, if you talk about internet-based delivery of any computing paradigm, then in that case, cloud definitely comes into picture. What do you understand by a cloud? Because right now, whenever you go with any online classes, if you go with Zoom, if you go with Google Meet, it's all on cloud. When you are using Gmail, it's all on cloud. If you want to go for real infrastructure, you go with Elastic Cloud Compute, it is all cloud. What is a cloud? Cloud is a business paradigm in which one or the other services will be offered to the users based on pay-as-you-go model. That means, on one hand, you have a cloud service provider which is offering you the services. On the other hand, you have the users who ask for those services. And the beauty of this kind of a system is cloud offers you infinite computation and infinite storage. For example, it doesn't matter how many pictures or videos or clips or text messages you have, you can always upload it on Instagram or Facebook or anything particular. If you want to go for a storage, you want 100 terabytes of storage, definitely that will be made available to you. So we say that since it is a business paradigm, definitely there are interests involved from the point of view of cloud service provider as well as the user. So a shop is successful only when both are benefiting from that. So the cloud model has been successful precisely because of this reason, that since business interests are involved, so the cloud service provider makes sure that the technology which is being offered to you or the services which are being offered to you are really up to date and maintenance free from your point of view. And from the user point of view, there is no maintenance required. There is no immediate investment required. So definitely they can simply go and avail the services, and it's very easy for the new organizations coming up when they are not really sure about the potential of the business, whether the business is going to survive or not. Then in that case, cloud becomes really useful, because if the business takes off, you can set up your own cloud. If the business doesn't take off, then in that case, you can simply shut off your the shop and come out with the minimum losses. So if you talk about cloud, in general, we say, can you talk it as a cluster? Definitely it's a cluster. Can you call it as a supercomputer? Definitely, since it is having infinite computational storage capacity, it is a supercomputer. Can you call it a data store? Definitely. Most of the time for general public, the cloud is used as a data storage space only. So all in all, can I say that it is a Superman? Definitely it is a Superman, but with not that sense of weird clothing. In general, we say, if I want to summarize, that the cloud means a lot of storage power, and lot of computational power which are placed together. Do you use cloud? Definitely you use cloud in various forms. YouTube is on cloud, Gmail is on cloud, any other email service on cloud, Twitter or X is on cloud, and you name it and you have it. So the basic benefits are for the user, it doesn't need any initial investment. So you are taking free to use the resource of your choice. And from the cloud service provider, it's like, offering computing and storage as a service, just like a shop. Basically, there are three models which are there in the case of cloud computing. The first one is software as a service, in which only the software will be made available to you. You cannot do anything. You either agree to the terms and conditions and use the software, and there you go. If you do not agree, you simply leave it, because ultimately it's your choice. In cloud, nobody will force you for anything. In platform as a service, maybe like if you want to develop any app, then you can use Google App Engine. So that becomes platform as a service, in which a platform is provided to you, in which you can deploy your services, you can test your services, or you can maybe develop your own service. Now, finally, there is infrastructure as a service, in which if you want the entire computational platform to be under your control, then in that case, all the computational servers will be given to you, all the supporting software will be given to you, and you are the master of your own machines and organizations. So that is the biggest umbrella as far as the cloud computing is concerned. But up till now, what I have discussed is cloud is totally business centric, in which there is a single owner, or maybe even if a number of owners are there, ultimately it belongs to the same organization, and they are responsible for the well-being and maintenance of that particular cloud. This brings me to another model of parallel computing, which is known as grid computing. Summarize, okay. So grid computing is something in which people tend to collaborate their idle resources when they are not being used. For example, if I say we have in JU a number of computers available which are not getting used at the same time. So what we say, those idle resources we can put together to be used as a collective powerhouse known as grid, just like what you call as an electric grid, in which those states which are not generating electricity are getting electricity from those states which are generating ample or surplus electricity. So it's just like pooling together your resources to come together and then addressing the computational problem. So since I have a limited time, one of the very simple usage of grid computing is like if you have a collection of computers in your lab, if you want to screen millions of compounds, definitely the same job can be divided among various computers and the result can be attained. So it's like a social platform in which distributed computing is achieved by people coming together and solving the problem by contributing their own resources. Last computing paradigm is Internet of Things. What do you mean by Internet of Things? It is like something which are up till now, what all can communicate on the internet. Only computers can communicate on the internet because they have a specific language. But suppose if you want to make the smart devices, like you want to make the light smart, if you want to make the fan smart, if you want to make the seat smart. So in that case, how is that possible? By the use of deployment of sensors, appropriate sensors to those passive devices, we can come up with a solution in which the physical quantity will be read and accordingly they'll be translated into bits and accordingly the data generated will be analyzed. I'm skipping many things. In general, you can see IoT as a network of networks in which many networks are coming together to solve the problem. For example, smart building comprising of smart telephony, smart maintenance, smart electricity, smart water, and so on. Therefore, to summarize, I would like to say that we evolve because we communicate. As you know very well, that fire was discovered once and it was shared later. DNA was discovered only once and later the information was shared. So I say, if more data is generated, then the data can be converted into information. This information can be converted into knowledge, and this knowledge can lead to what you call as when you reach the age of 80, oh, wisdom. So ultimately, it all starts with the input of data or acquisition of data. The use of IoTs are simply, since you people are biologists, like sensors can be put on animal life and you can see the vitals and you can monitor the vitals so that you get a plentiful supply of direct and indirect animal life offerings. I'm skipping that. Even better life of elderly could be there by putting the sensors, and in case any challenges there can be seen. So before Dr. Ranjana stops me further, I would like to summarize the thing by saying that definitely parallelism is the way ahead. And in this talk, very brief talk, I spoke about various important computing paradigms from multiprocessor systems to IoT, and they have applications in both compute specific and data intensive applications. So let me just conclude with two sentences. Where all these computing paradigms comes into picture. They come into picture, for example, if you want to go with your biological applications, for example, you want to sense the data, you want to generate the data, you want to have the acquisition of data, IoT devices comes into picture. If you have a huge collection of data that needs to be processed, cloud or grid comes into picture. If you have a comparatively smaller data set, then multi-computer or multi-processor system comes into picture. Biobank applications, the theme of this particular conference, you have a huge amount of humongous data. So ultimately, even if you want to go for AI-based prediction or AI-based analytics, how actually that will be done? So I am the person actually who works in the domain of how that computation will be done. And with this, I would like to say, although this is the trend up till now, but the future remains uncertain. You never know what new technology or paradigm will come up. And thanks to the sources, and thank you all for your patient hearing. Thank you so much.
I just announced तुम भी आ जाओ, मैं सीधे तुम्हारे टाइम आ जाओ।
Thank you. Thank you. Thank you. I hope it was useful.
I'm sorry, before delaying further, I am going to invite Dr. Papia Chowdhury, who is a professor in Department of Physics at JIIT Institute of Information Technology, Noida. She earned her master's in physics from Jadavpur University and completed PhD in molecular spectroscopy at the Indian Association for the Cultivation of Sciences in Kolkata. Her doctoral research focused on the photodynamics of industrially relevant organic biochronophores in various environments, including organized assembly. Dr. Chowdhury has established collaborative research efforts with renowned institutions both in India and abroad, such as IACS, DNCSR, BIT, Guwahati University, and so on. Her research encompasses the synthesis and characterization of capped and uncapped quantum dots, fluorescent and optochemical sensors for detecting environmentally hazardous metal ions and quantum dots as medical imaging markers, particularly for cancer cells. She has 95, more than 95 peer-reviewed publications in prestigious international journals, and she has made significant contributions to her field with the DST, DRDO funded projects and leads into industrial projects. She is an active reviewer of many journals, such as Journal of Physical Chemistry and Chemical Physics Letter, and I welcome Dr. Papia for her talk on green carbon quantum dots